so it's hard to look up here. So here are the correct answers for the homework last night. Number 1, the answer is 3. Number 2, 1. Number 3, 3. Number 4, 4. Number 5, 4. Number 6, 4. 7, 1. 8, 2. 9, 1. 10, 4. 11, 2. 12, 1. 13, 2. 14, 2. 15, 1. 16, 3. 17, 2. 18, 1. 19, 4. 20, 3. 21, 1. 22, 3. 24. No, did I say 23? Sorry, 23, 4. 25. Oh my gosh. 23 is 4. 24 is 4. 25 is 3. Now here's what I'm going to do. I want you all to find one that you want me to go over. So look at the ones you got wrong. Go look in the test booklet. See if you get why you got it wrong. I'm going to give you a couple minutes to find the one you want me to go over. So everybody get a number and put a star next to it because that's the one you're going to pick for me to go over for you. Every single person here needs to find one you want me to go over. Did anybody get 100?
Yeah.
So just find one you want that you got wrong, that you don't understand why. And you'll probably want to have your reference table handy.
I did do some of the package.
Okay.
I did pretty good.
Okay. I decided to shorten up the homework. So for those of you who have looked at the homework already earlier today, I decided to make the homework just 15 questions instead of 25, so that maybe you just try a little harder. Because last period told me that they didn't try very hard. All right, let's start. Chloe, can you tell me which one you want me to go over? 21. That was yours too? Perfect. I won't call on you unless you want me to go over another one. 21. So first thing we got to do, look at it. The geological cross-section below represents a portion of the Earth's crust. The rock layers have not been overturned. So we got some rock layers. According to this area up here, this whole section right here is an igneous intrusion. And they told you that these things are inclusions. The inclusions were most likely broken off from their original layers. And when do you think they got broken off? Let's read through the directions. So this is not something I've specifically taught you about. I've never even used the word inclusions. So you have to use what you know about rocks to try and figure it out. So this one is one I would expect people to get wrong. So by the way, it says, when did they get broken off? As the same time as the intrusion, at the same time of the crystallization of the magma. So this is magma. Did it happen then? Before the formation of the sandstone. So here's the sandstone way up here. Did they happen right before that? Or before the formation of the limestone? That's then. So when did these break off? And by the way, they're from this layer right here, because I know that because they match up with that. So when could they have gotten broken? What makes sense? When could they break off? So if they broke off because this magma came through, so they broke off at the same time that intrusion pushed through. That intrusion pushed through and broke off those rocks. I wouldn't, that's one we have not specifically talked about. And this is the reason why I've literally never seen a 100. This is some random question that I've never seen before. So that one is an unfortunate one. All right. Ted, which one do you want me to go over? 3. 3, which type of star has a surface temperature of 4,000 Kelvin and a luminosity 1,000 times greater than our sun? So did you guess? Yeah, this is a question when you're like, what the heck? Who cares? I don't know the answer. I'm not on Jeopardy. Why would I know this? Check your reference table. Here's the reference table about stars. So they said a temperature of 4,000. So that means we're somewhere here, somewhere on this line. And it's at 1,000 times brighter than our sun. So that's here. So something that is around here, which now I didn't even look at the answers. I should have looked. 3, is it a dwarf, a main sequence, a giant, or a supergiant? Well, looks like a giant to me, right there. Say 4,000 degrees and 1,000 times brighter than our sun is a giant right there. Victoria, which ones do you want me to go over? Number 6. Oh, and I don't even have to turn the page. How many days during 1 year is the sun directly overhead New York City at noon? Oh, this is a trick question. The answer is never. It is never, ever, 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 ever. Oh, sorry. Never, ever, 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 ever directly overhead in New York State at all. Ever, never. Trick question. 6. Connor, which one do you want me to go over?
24.
That's like really far away from what I was doing. Did anybody want me to go over 25 too? Did anybody get that one wrong? They were messing with you with 25. 24. What layer of the Earth's interior is inferred to be composed of solid nickel and iron and nickel? I'm looking at asthenosphere, stiffer mantle, outer core, inner core. That's page 9 of your reference table. Iron and nickel are either the outer core or the inner core. I'm not sure off this which one's solid, but if you look down here, to be a solid, it can't have melted yet. So in this one, in the outer core, the actual temperature is hotter than the melting point. If something's hotter than the melting point, is that going to be a solid or a liquid then? Yeah, this one's going to be a liquid. So that's not the answer. But here, I'm colder than the melting point. This one's going to be the solid. So that is the inner core. Riley, which one do you want? 14. 14, the graph below shows the relationship between the distance that wind blows over a large body of water and the height of the waves that are generated. A west wind blowing with the same velocity would generate the highest winds along the shoreline at, and then they give me cities. What should I do?
No.
Baloney.
Indeed.
So there's only one reference table that labels cities, and that's page 3. So the first thing I would do is find these 3 places. Here's Jamestown. Here's Oswego. Plattsburgh, way up here in the corner. And Riverhead down here in Long Island. So those are the 3 cities. And it says, so the distance of wave height, if you're right, distance the wind blows over a large body of water. So if it only blows a short distance over a large body of water, we have a low waves. If it goes a high distance over a large body of water, we have a high wave height. So first of all, which 2 can we eliminate completely? Which ones aren't going to have very strong waves at all? There's one that's really obvious. Jamestown, Oswego, Plattsburgh, or Riverhead. Which one's not going to have very high waves at all? Guys. Yeah, what do you see there, Briley? Plattsburgh. Why is Plattsburgh not going to have waves?
That's the ocean.
It's not on the ocean.
No, it is.
No, it's freaking not.
It's right in the middle.
No, it's not. What is this word right here, people? Vermont. Have you ever heard of the ocean named Vermont?
Oh, yeah.
Yeah, that's a state. That's not an ocean. So Vermont's not on an ocean at all. There's no waves happening at Plattsburgh. Could there be, so now Riverhead is down here near Long Island Sound. But what way does the wind blow according to the question? Says it blows from west. This way is west. Will Riverhead get any waves? It's not, there's nothing west. There's not really any water west of it. So that leaves these two. Who's gonna have bigger waves? Jamestown on the tip of this teeny tiny lake? Or Oswego on the tip of that very large lake? That one, Oswego. All right, I know I didn't get to some of you. Is anybody else dying to ask me a question about one of them? Like you really don't get it? Any of you want to pick yours that you wanted just because you really don't get it? No, you're all good. If you have more that you want me to go over, let me know. But I want to move on from that. So yes, you do have more homework in that. Hey, in case you didn't realize, the answer sheet is on the back of the little answer sheet booklet that I gave you. Got it? Answer sheets. Tonight's homework. So due tomorrow, due Thursday, is questions 26. So I guess it says 20. Oh, yeah. 26. I know it says 25, but I meant 26 through 40. 15 questions.
No, but I'm gonna do it.
Oh, you can't see what I'm, 26 through 40. Answer them on the answer sheet. Maybe this time I'll be serious and I'm not grading them if the answers aren't on the answer sheet. Got it?
They are? No.
Okay. So, yesterday's review. I told you you didn't have to do it, but you could.
Last day of school.
If you recall, I think this is a great way for you to study. A lot of kids don't know how to study. It was me. I didn't know how to study. In fact, earth science was my very first bad grade as a kid ever. Because it was my first Regents I took. And I didn't think you had to study. Turns out you did. And you really should study. The reason I say this is because we got stuff going back from September. This was the very first thing we learned in the school year. I want you to, what would I really want you to do? Answer this all on your own. Look up the answers, figure out what you know and what you don't know. Then go to Teams. We already went through this. You go to Teams. Go to Teams. There's my Teams. And it's always listed all nice and neatly here. Here it says review for 1-1 and 1-2 and 1-3. I will get to you. Hang on. And you click the link. And there's the video of me doing. It's basically just like if I had a whole extra day to talk about it. The video's there. It's 13 minutes long. Watch the video. Either check your work if you did it all on your own, or do it by watching the video. Whatever works for you, get it done. Extra credit. I'm doing this for every single chapter. So we're moving on to chapter 2. So I've got the same thing for chapter 2. We're going to start it in class, and then I'll post the video online. What?
Isn't there a factor that is there to teach us?
Oh, yeah. Sorry, it is like my job.
Yeah.
Yeah.
So give me the answer. So we do
I literally cannot give you the answers on the Regents. I could, 1, lose my job, to go to jail. You could go to jail, you could go to jail.
I'll bail you out.
You will.
Yeah, I'll bail you
So
out.
Mr. D, I handed those out really weirdly. This group doesn't have it yet, I don't think.
I don't think I could leave that.
No, I literally can. Group of teachers in North Carolina, like 5 of them went to jail for it. Anybody else need one?
For how long?
For changing the grades, it was considered like some sort of like, I don't remember exactly what it was, but they did go to jail for it.
How long do you?
I don't know that answer. All right, so let's start here. Chapter 2 was maps. It started off with the different spheres of Earth. And I don't want to start here because this is all kind of just like off the top of your head. You can get this from the video. I want to flip over to 2-3. So again, I would go to the video to get all of it, but now I want to make sure you're doing 2-3. This is the one people forget about. Contour lines. What the heck is a contour line or a contour map? It's the map with all the lines on it. Yeah, it is. I always call it connect the dots for slightly older kids. Connect the dots for slightly older kids was the stuff we did back in October. It made a comeback a couple chapters ago for weather. You do have to make sure you're really good at contour maps. First of all, what are the rules? Contour maps never or sometimes cross. They never ever cross. What happens if the lines are close together? What does that tell you? Steep slope. What happens if their lines are far apart? Gentle slope. What about the contour lines bend upstream? So first of all, what does upstream mean? That's the uphill one. So this means where it comes from. Downstream is downhill, so where it's going. Do they bend upstream or downstream? And let me show you a picture of what I'm talking about. Here's a creek, Snapper Creek. See how these kind of bend? See how they make V's? Do they point to where it's coming from or where it's going? Yeah, they point to where it's coming from. The other thing to remember is they open up to the water comes out of the V's. And I want to add that little note right there next to it. Water comes out of V. So right there next to it, water comes out of the V. Again, what do I mean? If you flip over the page and look at Snapper Creek, they point to where it's coming from. The water is also coming out of the V's. And how about the last one? Contour lines connect places of equal elevation. Yep. And no, we don't need to rewrite that. That would be a waste. What's a map scale tell you? And in case you forgot what a map scale is, there's an example at the bottom of the page. Distance, yes, distance between two locations. And a contour interval. Also, there's an example down here. It says contour interval 20 feet. Yeah, it's what the lines count by. So what lines go up by? What's the highest possible elevation? If the highest contour line of on a hill is 100 meters and the contour interval is 20, what's the highest possible elevation for that hill? What that means is, let's say we have a map and this line right here is 100. And the lines go up by 20. So that one's 80 and this one's 60, 60, 80, 100. 119, you got it. Here's how you figure that out. So you know they go up by 20s. So what would the next line be? No, if it was 100 was the last one, what would the next line be if they count by 20s? 120. Is there any 120s? How do I know there's no 120s? There's no line. So it could be anything between 100 and 120, and the highest possible number in between those is 119. By the way, that would be in meters. You should label that. You can do it with either an M or spell it out. If you don't remember what a benchmark is, that's a spot that marks the exact elevation. So somebody went with some fancy equipment and labeled that exact spot. Yeah, it's pretty fancy. But you need to do it every once, like you need to have some reference points here and there so you can then estimate everything else. What direction do streams always flow? Down. You cannot tell me north, south, east, or west. You can only say they always flow downhill. It can, but it doesn't always flow north. You got to take each direction at a individual. You got to look at every single creek to say that which way it goes, but you can't say they always flow north. The only thing you can say is they always flow downhill. All right, we got a little mini topographic map right here, and it shows spots X and Y. What's the contour interval? It's labeled 20. Sometimes they'll be labeled nice and easy like this one. Sometimes you have to figure it out. Now, what's the distance? How do I figure out how far apart they are?
60.
How do I figure out how far apart two locations are?
I'm going.
No, we can't count. That's talking about elevation. We use the scale on the bottom. How do we figure out, how do we use that thing on the bottom? You need a scrap sheet of paper. You all have random sheets of paper all over your desk right now. You have your reference table, you have your Regents test, you have anything. Grab a reference or some sort of scrap paper. Line it up between X and Y. Mark it off. Here they are. There's X, there's Y. Bring that down to the scale. So I'll wait till you guys do it. Then you're wasting everybody else's time. So mark off X and mark off Y. Bring it down to the scale. And yes, just like Hayden said, that's 2. Hey, Hayden, 2 what? Miles. Again, I know that because it says miles right there. How do you abbreviate miles, guys? MI. If you do not know how to abbreviate something, please do not guess. Because if you write 2 meters, just M, I'd have to mark you wrong. So now how do we do the difference in elevation between X and Y? This is where we use the contour interval. If this one's 500, what's X? They go up by 20. So there's 520, 540, 560. 560 minus 500 gives us just 60 feet. Now it says, what is the approximate gradient between X and Y? Show a work. That sounds like math, doesn't it? And we don't just memorize formulas. You have them right here. Gradient is change in field value divided by distance. What the heck does change in field value mean? So change in field value just means a change in whatever's being measured. So in this map, we're measuring elevation, but remember, sometimes it could be temperature, sometimes it could be pressure. So it's a change in whatever's being measured. So this time it's a change in elevation. We just did that right here. So that changes 60 feet when you walk from X to Y. Divided by distance, we already did that. We already measured that they're 2 miles apart. Which number goes into your calculator first? The top number. So 60 divided by 2 is 30. You don't have to convert. You got them right there. There's the units right there. Feet per mile or feet over miles. That means when you walk from X to Y, your elevation will change 30 feet for every mile you walk. All right. The back of that page, 9 and 10, is more of the same stuff. I want to make sure you know how to do profiles. So everybody turn to 2-4. You're going to need your scrap paper still. What's a profile? Okay, so it is, yes, it is all of those things. But in earth science, when I say a profile, I mean a side view. So I want to know what this hill looks like if I look at it from the side. And this is where it's like a graph, but not quite a graph. Yeah, we got to draw the shape of this hill. So you, like I said, you're going to need a scrap sheet of paper. Doesn't have to be a big one. My Post-it note works perfect. Does anybody remember the first thing I made you do every time we did one of these? And it seemed annoying, but I'm telling you, it's the first step. That actually wasn't the first thing. I always wanted you to label them first. So yes, your paper is going to go here. So I want your labels up here so you can see them. So you got to figure out what it is at A. So it's okay. So here they've got 3,000 labeled and they have 3,500 labeled. What do the lines go up by? 100. Now it also told you that right here. So what elevation is it at A, which is this line here? 3,400. And I told you to go ahead and label all of them. So that first one at A is 3,400. The next one over is 3,000 what? 300, because we're getting, those lines are going down. 3,200, 3,100. Yes, you got to squeeze them in. 3,000. What's after 3,000? 2,900. But what is the elevation at B? Yeah, that one repeats again, 2,900. Then once you have them labeled, the next step was to mark them on your scrap paper. So you line up your scrap paper. Remember, I don't ever like using the very corner of a piece of scrap paper. So you mark off A, you mark off B, and you just relabel. So A was 3,400. Then just mark all those little marks. So you've got a scrap paper with a bunch of little lines and you should label them all. I know. Then you bring your scrap paper down to what looks like a graph. Now remember, it's not really a graph, it just looks like it. Line up the A and the B. And then you just put the dots above the marks you just made at the right number. So that A goes up to 3,400. Put a dot. Actually, this time it says put an X. So you should probably do what the directions say. Then you go straight up from 3,300. 3,200. Now you'll see I draw a faint line as I go up. You can draw that, but you don't have to. And yes, the 2,900s repeat. And so you're going to start connecting them. But then when you get down to the 2,900s, remember, you can't go flat across. You either have to go down for a valley or up for a hill. You have to decide on your own if it's a valley or a hill though. So what you do is you go and you look. This whole section right here between, so where I just highlighted it pink, is that lower than 2,900 or higher than 2,900? And you just figure out the lines. Well, if that's 2,900, this is 2,800. You can see the pink is in between 2,800 and 2,900. So that's a curve down. Make sure you curve it down significantly, but don't let it touch 2,800. Towards which direction is Snapper Creek flowing? So remember, you look at the V's. The V's, according to what you wrote down before, it points to where it came from. So then that means it's going this way. What would you say? What direction is that? South. By the way, you should always check the compass. So yes, just in case, north is up here, south. Never eat soggy worms. So we're over south. You could have also said southeast. Either answer would have been accepted in this case. No, so you can't say it always flows. You have to look at whichever map you're looking at to say which compass direction. And this one specified compass direction, so not just which way, you can't answer it downhill. So that's all I wanted to do together. I already recorded the video for this. It will be posted on Teams. You can do 1 of the pages, 2 of the pages, 10 of the pages. It's all extra credit. And I don't know if I pointed this out to you guys. The extra credit's all going to be due the very last day of school. So you have some time to get it done. You already have some of the pages done. So all of you have some extra credit done. Starting tomorrow, I'll start checking the extra credit. I'm not prepared today. I'm not ready. So don't lose them. Bring them back to me. Oh, don't forget you also have homework. You guys have 5 minutes, 6 minutes. 6 minutes to do 15 questions or work on your extra credit. I don't want much chatting. I'd rather you not go on your phones and veg out. I would like you to work for 5 minutes, but I guess I can't force you.